want to start this video by first apologizing to Dave and my fellow classmates for not having my online learning environment in a shareable form right now. It turns out that Empower is still relatively new, and it's not easy for our tech administrators to actually enter in students or even teacher accounts. So unfortunately, I don't really have a great way for you all to log in and see what I've been working on. But I wanted to give you a quick glimpse as to the work that I have been doing. So I want to first show you what Empower looks like from a student perspective, and then I'll go in and show you what I've completed from the teacher's perspective. The way Empower works, it's a lot like a music playlist. You go through in a very linear fashion, although that need not be so, but typically you go through in a very linear fashion and you complete these activities one by one until you reach the culminating assessment or some kind of major wrap-up event at the end. So for example, when you click on one of these activities, I'm sorry, that's actually a sub-playlist, but you have these 3 activities within the sub-playlist. And this first activity starts by explaining the goals for the activity. And it's very clearly articulated, and it also provides the standard and the scoring guide for that standard. And on the target there, it said that our goal for this learning standard was to achieve a 3 at meaning I understand how a student would view their learning progress in the target browser. It's a bit ironic since you're unable to do that. Then once you've read through the goals, you can click on action, and this is where you actually have to do the work. So it goes through with an explanation of the work you need to do, and then it provides, in this case, an MP4. Sometimes there are worksheets. There may be links to other websites. You can put any resource there, really. And then the student is able to actually put their response in here. They can draw it, they can add an attachment, they can provide a link, or even put in a Google Drive document. Once they save it, it's entered into their locker. And after completing it and submitting it through their locker, they can request feedback from the teacher. Now, this particular activity has numerous steps. So here's the first one where it tells you to click on the icon and watch the first tutorial video. So you click there and watch the video. But then if you click this scroll button, here's the second task for this activity. And it says that you need to hit the arrow to the right of this message to go to the next step. Then we go to the next step, and as you can see, there can be multiple steps to each activity. Each playlist or sub-playlist in this case can have multiple activities, and each activity can be a graded assignment. So this is what it looks like from a student perspective. And again, I apologize that you don't have access to this because it is kind of a neat resource. And there are a lot of really cool tools that I'm looking forward to using this year, including the ability to message a student back and forth, and it actually automatically records the student grades in a gradebook or assignment gradebook. So there are a lot of really neat toys or tools, but unfortunately this video is somewhat limited in what I can show you. So for the purpose of this class, I created a matter unit, and as you can see, this is my first playlist. So I start with the big idea, what's the purpose of studying matter, and then I go through and I have these sub-playlists, which are really the individual standards for a large topic unit. For this week 4 activity, I decided to focus on the atomic structure as my little sub-playlist, and you can see I start with a big idea. So what are the major parts of an atom? And the students can click on that and they can see not only the essential question, but also what we're actually going to learn, and more importantly, why we're going to learn it. Once students have seen that, they can start in on the history of the atomic theory, and I have a little check-in quiz so they can check their own progress and see how much they actually understand. Now, because the history of atomic theory isn't really a standard, I have not added a target to this particular quiz. It's really just a practice to make sure that the students are understanding that there were multiple models of the atom throughout history, and to understand how the how our understanding of the atom has evolved over the years. Once students have completed that checking quiz, though, that's where the real fun begins. And we get into subatomic particles. Now, this actually is part of the standard. But as you can see, if you were to look on the learning scale, or the scoring guide in this case, comprehension, like drawing and labeling an atom, including electrons, protons, neutrons, and nucleus, this is a level 2. So for this particular activity, I set that my maximum achievable score at a 2. So the students are going to know exactly what they're going to need to do to achieve that 2. So then my action plan, or the steps that students will need to complete to prove that they understand this, my first step is actually I provide them notes from the class in case they miss something. So I have a handy resource here that talks about each of the subatomic particles. So if students missed class or didn't quite understand the lesson as we were going through it at the time, they can actually look through the notes. And then in that submission space, the students will have an opportunity to draw and label all major parts of the atom. Then I ask them to write at least 3 facts for each subatomic particle. And again, in the submission space that students will see in their student view, they will have an opportunity to actually draw out that atom. So they know exactly what's expected of them to achieve that level 2, and they're able to submit it right through Empower. Once students have completed the subatomic particles, they can go to the next step in their playlist, just as if it was a playlist on their iPod. So for the next step, which is by far my favorite, making atoms, students will actually have a maximum achievable score of a 3, which is more analysis on Bloom's taxonomy, and they have to compare the atomic structure of 2 different atoms, draw a model of different atoms, and use them to describe why certain atoms react in different ways. So, under my action plan, I provide students with a really neat outside resource called Building an Atom, and I ask the students to practice making the following atoms: a neutral helium atom, a positively charged lithium ion, a neutral beryllium atom with an atomic mass of 9, a boron ion with a charge of -4, a carbon ion with a charge of 2+ but an atomic mass of 11. So students know exactly what they can do for practice, and they can click on this resource, which has been blocked. And they can actually build an atom. And this is the outside resource I really wanted to stress with this particular standard, because students can add protons and they can add neutrons and electrons, and they can see how what they're doing is changing the atom. So in this case, it has a mass number of 2. It's a neutral atom. It doesn't have a charge. But if they were to add electrons, you can see that the charge has changed to a negative charge, but the mass number has stayed relatively the same. So students can go through and actually play and interact with atoms, which is really, for students, a very abstract concept. But they can play with it, and they can see just how what they're doing is changing the identity of the element. So in this case, if I were to add another proton, the students would instantly see, oh, now I changed my atom. I no longer have a hydrogen atom, now I have a helium atom, and my mass number has gone up to 3. So the goal here is to provide students with an opportunity to actually play with it and see the consequences, or see how what they do changes the overall charge or identity of the element. So that is part of the practice piece. And then on that same resource, if you back up, on that same resource they also have games. So for the second step in that particular activity, I have students actually choose one or all games, so that provides the choice component, and they can actually see, okay, what has 9 protons, 10 neutrons, and 9 electrons. Okay, so we go through and we see, let's check, is it neutral? It is neutral, so we check it, and it's correct. So again, this is a really fun way for students to check their understanding of atoms and how they would be located on the periodic table. You can also go through, and there are a few other different games that would be equally engaging and just show a slightly different perspective on this on atoms and elements. So that would be the second step of the playlist. And then the third asks that the students actually compare and contrast a boron ion with a charge of -4 and a neutral boron atom. So this is going back to that learning goal, or to our standard, and it's asking the students, how are the atomic structures similar and how are they different? And then I want the students to compare the two atoms in 3 to 4 sentences. And again, they can submit all of that on Empower. Once students have completed the Making Atoms activity, they can go on to Element Reactivity, and again, they're going to see the same learning scale right there. They know that their maximum achievable score is a 3. They know the description of this particular activity and why we're doing it. And then when they go to their action plan, they see that now we're actually getting into valence. So because atoms want a full valence, or a complete set of electrons in their outer energy level, they will take, give, or share electrons with other atoms. And then in this activity, I want them to actually just watch a video. Oh, looks like my link isn't working. I'll have to fix that. But they watch a PBS video on valence electrons and how it affects the reactivity of an atom. And then students will need to consider the salt compound, or sodium chloride, and explain why these two elements, sodium and chloride, are drawn to each other. So why are these atoms more reactive than others? And again, they can write and submit their response right here in Empower. And then finally, to give the students a little bit of voice and choice, I have 2 different activities. And students will need to choose a minimum of 1 activity. Now, because we are standards-based, I need to provide my students an opportunity to go above and beyond. So students obviously know, looking at the learning scale, what they need to do to get a 3. Here's another activity that they could do to demonstrate, yes, I understand everything at that 3 level and I have no problem performing it. If students want to go above and beyond, which is highly encouraged, they can actually check on this activity, which is for a level 4. It's designed for level 4. It's going above and beyond. And they can see that I'm actually going to have them doing research on the 2 atomic bombs, Little Boy and Fat Man, that were dropped on the Japanese cities of Hiroshima and Nagasaki. And then they can build on their understanding of the atom and atomic forces by researching and preparing a statement regarding nuclear warfare. So students will go into their action plan, and I provide a video here from YouTube that explains how nuclear bombs actually work. Now, because I don't want to provide students with too much information, and I really want them to kind of take what we've discussed in class and go above and beyond with additional research, I really provide just a prompt and the YouTube video with basic information, and encourage them to go ahead and conduct and cite additional research as well. And their final product, again, can be submitted right here on Empower, and it's a 1 to 2 paragraph description of nuclear fission and how it applies to nuclear warfare. So again, the point of this level 4 activity is for students to take the understanding of atoms and nuclear forces within atoms and to actually apply those to a different situation. And I really like any opportunity to relate their knowledge in science class to other content areas, in this case being social studies and a little bit of English in the writing component as well. So again, I want to apologize for the awkward video here, but I wanted to give you an insider's look as to what I've been doing with Empower. I can provide individual resources and links to everything that I cite here on my playlist. But if you have any questions regarding Empower or the work that I've been doing, please feel free to leave me a message, and I would be more than happy to respond. So thank you, and I hope you found this information